All right, so here's the test review. So the first one does say, use your knowledge of transformations to graph the following equation. State whether each is growth or decay and give B. State transformations, the y-intercept, domain, and range are for each problem. So let's go ahead and take a look at this here. All right, so for the first question, let's go ahead and take a look at this here. So it says y equals 4 to the x minus 2 plus 3. First off, the b value right here is 4. And since that's greater than 1, it's growth. In terms of transformations, x minus 2 is going to be to the right 2. Plus 3 is going to be up 3. So in case you do need to see this, a, b, x minus h plus k, and we know that a is your vertical stretch, compression, or reflection across the x-axis, h goes left or right, it's the opposite of what you see, and k goes up and down. Now the domain for this graph, really quickly you can just type these into Desmos, so I'm going to go ahead and do that here real quick. Let's kind of shut down that a little bit. There we go. All right, let's type this in here and let's see what it says. So y equals 4 raised to the x minus, let's see, x minus 2. All right, and then plus 3. All right, from here, we can see the domain is going to be all real numbers. And we can touch the y-intercept and see it's at 0, 3.063. So the domain is going to be all real numbers and negative infinity to infinity. And for the range, that up 3 means the asymptote goes up 3 units, so it's 3 to infinity. And the y-intercept, I just clicked on it, was 0, 3.063 if necessary, right? All right, for the next one, number 2, once again, the b value, you can graph this, I'm not going to graph them, is 1/3, which is less than 1 but greater than 0, so that's going to be, my b value is 1/3, that's going to be decay. Transformations, this goes left 1 and down 4. Domain is not going to change, it's always going to be all real numbers for an exponential unless somehow it is restricted. The range is dependent on this right here, so that goes down 4, so it's going to be -4 to infinity. So really quickly, graphically, if you wanted to take a look at this, when you type it in, let's see, y equals 1/3 raised to the x plus 1, and then we have -4. So you can see from left to right it goes down as opposed to going up, so it's going down. Y-intercept we can just touch right here and see that it's 0, -3.667. All right, for the next one, be careful since it has this negative right here. It reflects across the x-axis, and this one goes down too. But since it reflects across the x-axis, our b value is 3. It does represent growth, but it is reflected across the x-axis, so really the answer is none, but if you really had to pick an answer, it would be growth, okay? So just be careful on that. It is growth, but it's reflected across the x-axis, so it is a little bit different. Domain is going to be all real numbers. And now, so graphically, we're going to take a look at this one real quick, because since it is reflected across the x-axis, that's going to look a little bit different. So I'm just typing it in real quick, and -2. All right, so this is what the graph looks like. This time you can see it's facing down, still all real numbers, but it's gonna be from -infinity to this right here, which looks to be -2, right? So that's -3, so y-intercept is 0, -3, and the asymptote moves down 2, so it's gonna be from -infinity to -2, and neither one is included. And once again, you can make those graphs on your own. I'm not going to do that. It's not too easy. Just plot one point and make a rough sketch. All right, now for number 4, 5, and 6, there are rules for this. A has always got to be positive, so the a value in front of each one, a is greater than 0, so 1, 1, and 1, they're all, or 4, they're all greater than 0, and they're positive. And then the negative right here, so if it's negative, it is decaying, and if it's positive, it's growing, right? So let me just show you the first two real quick so you can kind of see what they look like. So y equals e to the negative x. So let's take a look at this one here. So y equals e raised to negative x. And we can see this one is decaying. So I'm just gonna put the letter D for decay. And for the next one, it is 4x. And this one we can see from left to right it's going up, that is growth. And this one, because this is positive and this is negative, it should be decay, but we're gonna just verify that. So it's -2, put a 4 in front, and we can see that it is definitely decaying from left to right, it's going down. All right, on to number 7. It says the value of a mountain bike, y in dollars, can be approximated by this model here, where t is the number of years since the bike was new. Answer the following questions regarding the formula. So what is the initial amount? So this is your initial amount. So that's A, which is $200. I'm assuming it's dollars. The decay factor is this number here, 0.75. To figure out the percent decrease, since it's decreasing, you're going to take the 1 and you're going to subtract the 0.75, which gives you 0.25, and that's actually a percent. We got to make that a percentage, so move it 2 to the right, and that's going to be the percent decrease of 25%. How much will this cost in 5 years? So I don't really want to switch to the calculator, so I'm just going to use the graph here to kind of help me get the answer real quick. So let's go ahead and type in this equation here. Y equals 200, 0.75 raised to the, and it said in 5 years, so time is 5. We can see 47.4609. So let's just round it to 2 decimal places. So 47.46. How much will it cost in 5 years? So $47.46. It's money, so it should have been 2 decimal places. Estimate when the value of the bike will be $50. Okay, so let's go ahead and change this to an x. So this is the exponential decay graph because it is getting smaller, 0.75. Then we're going to type in when will it be $50. So y equals 50. All right, and let's go ahead and get there. Okay, so right here at this intersection, when we touch it, we can see that in 4.819 years, it will decrease to $50. So we're just going to put 4.82 years. All right, and there's that problem there. All right, let's keep going. All right, on to number 8. So this one says the population P in thousands of Austin, Texas during a recent decade can be approximated by this equation here, where T is the number of years since the beginning of the decade. Answer the following questions regarding the formula. Okay, so the initial population, it looks like it'd be 494.29. That's in thousand. And that is in thousands. So I would say it's 494,290, but we'll just put it like that. My growth factor, 1.03. And this time, what is my percent increase? So I'm going to take 1.03, and this time I'm going to subtract 1 from it, and then we can see it goes up by 0.03, which is 3%. What will the population be in 12 years? Okay, so this one, I'm just going to type it into Desmos. So y equals, as you can see, I'm typing in y equals 494.29, parentheses, 1.03, close parentheses, raised to the, and it says 12 years, so 1, 2. And we can see 704, so what will the population be? 704.739, so 0.74 thousands. So really it'd be like 704,739 people. Okay, so but I'm gonna round up the way they did on the paper so there's no confusion. All right, number 9. For this one, a car is originally priced at $35,000 and it loses 5% of its value each year. Okay, so what is the initial amount? Well, that's $35,000. What is the percent decrease? Well, it's decreasing by 5%. And then what is the decay factor? So if you think about the equation, we have y equals a, and it's decaying because it's losing 1 minus r raised to the t. So I'm just going to write an equation, y equals 35,000, 1 minus 0.95, sorry, 0.05. Got ahead of myself there. And then the equation is y equals 35,000, 0.95 raised to the t. And because this is 0.95, it is losing. It is depreciating. So what is the decay factor? Well, the decay factor is going to be 0.95. And then from here it says, what is the value of the car in 3.7 years? All right, so here we're going to type in this equation, y equals 35,000. We have 0.95, and we're going to raise it to the 3.7 years. And we can see it'd be $30,008.13. So $30,008.13. All right, how long will it take to depreciate to a value of 23,500? So, oops, I forgot the 7 here. So let's go ahead and fix that answer real quick. So we have $28,949.787, so 79 cents. All right, how long will it take the value to depreciate to a value of 23,500? So we're going to take this 3.7, change it to x. We're going to go to y equals and type in 23,500. And now we're going to zoom in and see if we can find that intersection. So you can see there it is. So really quickly, I just moved the thing around until I got this. So click here, and we see in 7.766, we'll say in 7.77 years, it'll depreciate down to that. So approximately 7.77 years. So there we go. All right, the next one, number 10. It says a new and rare presidential $2 coin has been projected to appreciate. So appreciate is growth. So y equals a 1 plus r raised to the t power. So my initial amount is $2. 1 plus 33 would be 0.33 raised to the t, and then y equals 2. 1 plus 0.33 is 1.33 raised to the t power. All right, so the initial amount was the $2. What is the percent of increase? Well, they told us it was 33%. What is the growth factor? Growth factor right here is 1.33. And then what is the value of the coin after 2 years? So we're just going to change this t to the number 2. So let's go and do that real quick. So y equals 2 parentheses 1.33 raised to the 2 years, 2. And we see 3.537, so $3.54. All right, so that's how much it appreciates to. That's the value in 2 years. All right, number 11, you deposit $2,000 in an account that pays 7% annual interest, compounded monthly. What is the value of the account after 6 years? How long will it take for it to double? Okay, so for this problem here, the equation, let's see if I can write it over here. I'll write it here. Y equals the principal. Sorry, let's do A of t because that's what the proper formula is. A of t equals principal 1 plus the rate divided by the number of times compounded in a year raised to the number of times compounded in a year times the number of years. Okay, so for the first one, A of t equals, so the principal is 2,000. The initial amount, 1 plus the rate is 7, but we have to move it 2 to the left, becomes 0.07. It was compounded monthly. There's 12 months in a year, and then 12 times the number of years, which is 6. So we just take this and we plug it directly into Desmos the way we see it, whether using the scientific calculator or the graph, the answer should still come out either way. So I'm just going to use y equals, so 2,000, 1 plus, division, let's go with 0.07. over 12 raised to the 1, 2, and it's gonna times 6. All right, and I get 3,040.21. So it'd be $3,040.21. All right, for part B, how long will it take for the balance to double? Okay, so if we started with 2,000 and we're trying to make that double, so let's put an x here. 12x. 12 and x. And we're trying to make it double here, so notice I'm gonna just doing this, I'm gonna zoom out. All right, let's get over here. And we're trying to see double, so 2,000 doubled is 4,000, so let's go y equals 4,000. All right, and then we can see the intersection is right here, so I'm gonna click on it, and in 0 years. So let's take a look here. Did I make a small error here? 2,000, let me see my equation. 2,000, 1 plus 0.07, 12 raised to that. Okay, there we go, there it is. So in 9.931 years, so in 9.93. So I didn't zoom in close enough, so make sure you are doing that because it was giving me the y-intercept when I was looking for the intersection. So in 9.93 years, it will double. So once again, when you're looking at this, just make sure you see that I said y equals 4,000 because this is 2,000 doubled. Okay. Let's take a look at the next one here. Now it says, Maria Gonzalez needed to decide into which bank to deposit her $3,000 savings. Bank 1 offered her 4.7% interest compounded daily, but she had to keep her money there for at least 4 years. So meaning she has to keep it in there for 4 years. So let's go with Bank 1. And that's going to be A of T equals, so the principal is $3,000. 1 plus the rate was 4.7, so we move that 2 to the left, so that's 0.047 over compounded daily is 365. Again, it's n again, so 365 times the number of years, which is 4. All right, for the next one, we have Frost Bank. And A of T equals, so let's see, they offer it 4.8% interest compounded semi-annually with the same condition that she has to keep her money in the bank for at least 4 years. So again, the initial amount is 3,000. 1 plus the rate is 4.8%, so we move it to the left, 0.048. Over this time it's semi-annually, so that's going to be 2 times a year, raised to the 2 times 4 years. Okay, so we're going to type these into Desmos and see what exactly it does give us here. Okay, so go ahead and type these in here real quick. So the first one, y equals 3,000, parentheses 1 plus, divide 0.047 over 365, raised to the 365 times that. All right, so I come up with, for the first one, $3,620, 0.456, so 0.46. So that's how much she would make if she did Bank 1. For the second one, let's go and do it. Y equals 3,000, parentheses 1 plus, divide 0.048 was the compound this time. Let's see, over semi-annually is 2, raised to the 2 times 4. All right, and this one we can see is $3,626 and 777, so 78 cents. All right, so here we can definitely see the two values. Which bank should she go with? Obviously, it should be Frost Bank because she's going to earn the most interest back on that one right there. So hopefully you can see those two answers, and that's why she should go with the Frost Bank. All right, let's go ahead and keep going. Use your knowledge of transformations. So really quickly, so we're looking at this one, y equals a log base b of x minus h plus k. So a, again, your vertical stretch, vertical compression, reflection across the x-axis. H moves it right or left, and k moves it up or down. So for this one, we have a 3. That's a vertical stretch by 3. This one is left 2, and this k is down 4. The domain is going to be based on the vertical asymptote, so you can go ahead and type this in, but the left 2 is what affects your asymptote, so it moves to the left 2 units, and that's going to be -2 to infinity. If you want to double check that, type it into the Desmos, and the range for this one is going to be all real numbers. Now I'm just going to show you how to type it in. just in case you've forgotten how to do this in Desmos. So when I look at this here, so the first thing you're going to press, I think, is functions. You're going to go to miscellaneous and the log base A. So right here, it's log base A if you need it. The base is not 10. So in this case, the base was 2. So let's go back to the front. So let's go y equals 3 log base 2 of x plus 2. And then we have minus 4. All right, so we can go ahead and just zip on down over here. We can zoom in a little bit. And there we go. So we can see that it has definitely moved to the left 2 units. I'm pretty far out, but it's moved to the left 2 units, so the asymptote just continues along this line. And so we can see the left 2, the point did go down 4, and the range is from all real numbers, and the domain is -2 to infinity. Okay. All right, for the next one, I'm not going to use Desmos. If you want to, you can definitely check it. So first, this negative reflects across the x-axis. This one goes right 5, and this goes up 2. All right, for your domain, since it reflects across the x-axis, it's facing down, so that's not going to affect your domain, right? This one here is right 5 is going to affect it, so it's going to be from 5 to infinity because it went right 5, so 5 to infinity. The range will not be impacted, it's just going to be all real numbers. Once again, type that into Desmos, you can take a look at that. All right, so you're going to write each equation in logarithmic form. So you start with, so let's see if we can write this equation. So we have, however you want to write it, a to the m. Let me see. Let's just go for it. So when we're doing logarithmics, we start with the word log. Remember, the base is the base. This is base 3. Logarithms find exponents, so this 4 is what it equals. And then it's 81 is the argument. So log base 3 of 81 is equal to 4. And you can find it just, I would have my notes ready to use that formula. So log, the base is 1/4. Logarithms find exponents, so -2 goes here, and your argument is 16. So log base 1/4 of 16 is equal to -2. Now, converting to exponential, you're just going backwards. So you start with the base, so 6. Remember, logarithms equal exponents, and 6 squared is 36. 2 is my base, this is my exponent. 2 to the -4th is 1/16. Okay, so just make sure you know the pattern, have your notes by you so you can reference that. For these ones here, to evaluate it, you could definitely use a calculator on these. Let me just kind of show you, because on this test, that's really your choice, right? If I did, so let me show you. If you open it up, you go to functions, you can do miscellaneous log base, and this one is 6 and 1, and you can see right there it says it equals to 0, right? The way I'm going to show you, that's like I said, you can definitely type this into Desmos and get your answers. It even says equals to 0, right? What I'm going to do is I set them equal to x. I rewrite them in my exponential form, so 6 to the x equals 1, and 6 to the 0 power is equal to 1. For the next one, we set it equal to x, so 2 to the x equals 1/2. For this one here, I'm going to move the 2 to the top, and pretty much what happens is the exponent becomes negative, so then we can set the exponents equal to each other, x equals -1, and that actually is solved. Okay? And once again, you can definitely verify this in the calculator. So set this one equal to x, so 9 to the x is equal to 9 to the first. Since my bases are the same, my exponents are equal, so x is equal to 1. Okay, for the next ones, evaluate each using the properties of inverses. So pretty much, you can set them equal to x, or you can convert them to their other form, or you can type them into Desmos. I'm going to show you how to just set it equal to x. So base exponent equals 8, so 2 to the x equals 8. So the base is going to be 2. 2 to the 3rd power is 8, so therefore the bases are the same, the exponents are equal, so x is equal to 3. For this one here, again, log base 5, actually let's just set it equal to x. So we have 5 to the x equals 125, so my base is going to be 5. 5 to the third power is 125, so bases are the same, so exponents equal, x equals 3. These ones, 24 and 25, are going to be the inverses of each other. So you have a base raised to a logarithm, they have the same base. So if you cross those out, you're left with 7. Over here, same thing, you have a base of 10. If it doesn't have a base, it's a common logarithm, so you assume the base is 10. Cross them out, your x, the argument is your answer, so it equals to x. So that's using inverses. All right, let's take a look at these last few problems here. All right, so this is your expanding, right? So remember those 3 rules. So if you are multiplying, you expand by addition, right? So this is going to be ln of 10. And remember, all of them have the same log to the same base. So ln of 10 plus ln of x cubed plus ln of y. And then last here, you can't have these exponents. We're going to move this to the front. So our final answer is ln of 10 plus 3 ln of x plus ln of y. All right, for the next one, we have a division sign so that we expand it by subtracting. So we have log of the top, so log of 8, minus log of the bottom, log of y to the 4th. Again, we take this exponent, move it to the front, so we have log of 8 minus 4 log of y. For the next one, again, we have a subtraction here because of the division, but we also have a multiply there, so that means we're going to add. So let's do the top first. So log of 3 plus log of y, because they're being multiplied, minus log of x cubed. And then last, we're going to move this 3 to the front, so minus 3 log of x. Sorry about that. All right, let's take a look at the next one. Again, they're being multiplied. So log of 4 plus log of x squared plus log of y. And then again, we take the 2, we move it to the front. So log of 4 plus 2 log of x plus log of y. All right, on to the next one. So it's just 2 numbers being multiplied, or a number variable. So make sure they have the log with the same base. So log base 3 of 4 plus log base 3 of x. And for 31, so this one I'm going to go straight to the answer. So it'll be multiplied again. So log of 3. And I know this exponent is going to move to the front. So plus 4 log of x. If you want to go through and put x to the 4th and then move it to the front, that's your choice. All right, we're down to the last ones where we're condensing them. So when we condense it, we only make one logarithm. And remember I showed you that rule. Positives on the top and negatives are going to go on the bottom, okay? So the first thing we do with these is we take the exponents, the coefficients, and move them to the exponents. So ln of 7 squared minus ln of 4 cubed. 7 squared is 49, and 4 cubed, 416, 64. And then last, my last answer, 1 logarithm, so you have to only have 1. And then positive 49 over negative 64. So ln of 49 over 64. All right, for this one here, I'm going to go straight into making my coefficients into exponents. So they're minus and minus. And this is the only positive one. So I start with 1 log only. Fraction bar because I do see 2 subtractions. So 5 is positive, that's going to go on the top. X cubed is negative, and so is a 3. So on the bottom, we're going to have 3x cubed. All right, for number 34, once again, let's take these coefficients and make them exponents. And none there. So log with no base, and I see a subtraction, so I put a division bar. So which ones are positive? Well, x to the 4th is positive, and 2 is positive. So on the top, we're going to have 2x to the 4th. The only one that's negative is negative log of y to the 5th, so that's going to be y to the 5th in the denominator. All right, for the next one, there is nothing else to do, so log of 7, and it's going to be 4 times 6, and 4 times 6 is 24. For the next one, let's go ahead and move these coefficients to exponents. So 3 squared is 9. 2 to the 5th is, let's see, 2, 4, 8, 16, 32. Minus log of 8. So we start with a log. On the top, we have 9 times 32. And the 8 goes on the bottom. So I'm going to do this in Desmos real quick because actually 32 divided by 8 is 4. 9 times 4 is 36. You may have to verify that one, but I'm down to the last one. There's a minus sign, so log base 4 of 7 divided by 10. All right, other than that, that's the review. If you have any questions, send me an email, but I hope you have a good one.